In this particular example, I'm going to use StatCrunch to test a hypothesis of a mean. I'm given the fact that the mean of what I'm testing is the null hypothesis that the mean is 100 and the alternative that is not 100. I've run a sample and I've come up with a X bar mean of 105.7, sample standard deviation of 8.9, and n is equal to 18. Now the text tells you to modify the standard deviation by the square root of n to get the standard error. That's fine, but if you're doing this, the technology will take care of that for you. So I'm going to go to a t-stat one sample with summary, and you'll notice that it asks me all the right questions. So it says, okay, what's the mean of the sample? Well, it's 105.7. The sample standard deviation is 8.9, and it asks for the sample size. So it's going to do this modification that's explained in the text and in the help me solve it if you choose to do it by hand. This is a hypothesis test, but remember, hypothesis tests, we have to account for alpha, and we do that within the confidence interval information. So the complement of 0.01 is 0.99. So I'm going to make that level first and then come back to the hypothesis test. My null hypothesis is that mu is equal to 100. My alternative is not equal, so I'm going to leave that alone, and I'm going to compute. And I'm going to get my values. So my test statistic is 2.717. I'll make a note of that. Test statistic is 2.717. Okay, and the p-value, I'll make a note of that. The p-value is 0.0146. Okay, so now, if I'm going to do the classical approach, I need to know the critical value for this particular, and it's a two-tailed test, remember that. So now I'm going to come back over to stats calculators, and I'm going to use the t-calculator. And remember, with one of the other videos we did this, I need to know that value. It's a two-tail, so I have to split the alpha, and my degrees of freedom is going to be 17, 1 less than n, and I'm going to split the alpha, the 0.01, into two sides, because I only can put half of it in each side because the alternative is not equal. And I'm going to compute, and my value, if you'll notice, is negative 2.89 or 2.90. So now look at what my test statistic was. It was 2.7. 2.90, 2.7 is here someplace. So it's not in the critical region. It's not beyond the critical value. So we would fail to reject the null hypothesis based on the classical method. Now, if I go to the p method, I'm comparing a negative 0.0146 with alpha, which is just 0.01. Is p-value less than alpha, less than or equal to alpha? The answer is no. So therefore, even with the p-value approach, I would fail to reject the null hypothesis. And my conclusion would be that there is not sufficient evidence to support a claim that the mean is not equal to 100. And that would be solving this as a hypothesis test. Please run this again if you want to refresh your memory on how to find these values.